Hey everyone, thanks for joining today. I am excited to walk you through PyFlow, a modern workflow orchestration platform we have built for data teams who are tired of dealing with heavy, complex tooling. Let me take you through features of our product. So the first thing you'll notice when you land on our page is our core promise, which is orchestrate your data without the chaos. That really captures what PyFlow is about. You can see a live preview of dashboard right here, showing real workflows, active runs and system status. It's clean, intuitive, and it's already running. Now, before we talk about what PyFlow does, let's talk about why it exists. If you have worked with traditional orchestration tools, you know the pain, right? You're dealing with heavy infrastructure, complex setup that can take weeks, constant maintenance overhead, and when something breaks, debugging is very difficult. The visibility is just not there. These tools were built for a different era, and honestly, they slow teams more than they help. So the solution we are proposing is PyFlow. So PyFlow was built to fix exactly that. Our philosophy is simple, reliable, and scalable. You get the power of code-based workflows, full Python DAGs that you can version control with Git without having to manage any infrastructure yourself. That is zero infra management, a GitOps native workflow, and instant scalability. And as you can see in this code snippet, defining a pipeline is incredibly straightforward. A few lines of Python, set your dependencies, and you're done. Let me brief about the features. So let's look at what's under the hood of PyFlow. So PyFlow gives you code-based tag definitions. So everything lives in your repo. Automatic cron-based scheduling with full time zone support. Smart retry and failure handling with backup policies, so flaky tasks don't ruin your day. Parallel execution for independent tasks, a real-time monitoring dashboard, and GitHub sync. So you basically push to your repo and PyFlow automatically picks up and deploys your changes. No need for manual deployments and continuous integration pipelines to configure. Now let's understand from higher perspective that overall workflow of PyFlow. The workflow is dead simple. Step 1 is to define your pipeline logic in Python. Step 2 is that you push it to GitHub. In step 3, PyFlow detects the change and executes automatically. That's it. From code to production in seconds. Your team focuses on logic, we handle everything else. If your team is spending more time fighting your orchestration tool than building actual pipelines, PyFlow is worth a serious look. We'd love to get you set up with a hands-on demo or walk you through the documentation. Feel free to reach out. Now my teammate will explain the working.
Alright, let's jump straight into the application. So this is the PyFlow dashboard. At the top, the first thing you see is the overall system health status. Here we can see that the scheduler is healthy, the trigger is healthy, and the DAG processor is healthy. This basically tells us that all the core components responsible for the scheduling and executing the workflows are running properly. So even before looking at any workflows, we already know that the platform itself is stable. Now just below that, we have a quick summary of our workflows. On the left, you can see that the total number of workflows registered in the system. In the center, we have the number of active workflows, meaning the workflows that are currently enabled and ready to run. And on the right, we have the number of failed runs in the last 24 hours. This section gives us an instant full check of the entire platform without clicking into anything. So from the monitoring perspective, everything important is visible right here on the home screen. Now let me show you the workflow page. This is where all your pipelines live. Each row here represents a single workflow. You can see the workflow name, the owner, the schedule it's running on, whether it last ran, and a quick view of its recent execution status. So at a glance, you can understand what's running and how often it runs and whether it's healthy or not. On the left side, you will notice the toggle switch. This allows you to pause or unpause a workflow instantly. So if you don't want a particular DAG to run on its schedule anymore, maybe you are doing maintenance or testing something, you don't need to delete it. You simply flip the toggle. It's quick, clean, and very straightforward. Now, one important thing to note, you don't upload the DAGs through this UI. In PyFlow, workflows are created as a code. You write your pipeline in Python, push it to the Git, and PyFlow automatically detects and registers it. So the UI is mainly for monitoring, managing, and triggering the workflows, not for writing them. So let me show you that also. As I mentioned earlier, we don't create workflows from the UI. Instead, we define them as a code. Here is an example of real production style pipeline. This one is called Snowflake Daily Ingest. At a high level, this workflow is designed to run a Snowflake ingestion process. It supports both the full load and incremental load modes. When the workflow is triggered, it checks a parameter called full load. If the full load is set to true, it runs the full extraction and loads the stored procedures in the Snowflake. And if it's false, it runs the incremental version instead. So essentially, this single workflow can dynamically decide which pipeline part to execute based on the runtime input. It also accepts the parameters like process date, app code, and the full load flag. This makes the workflow reusable and flexible. You don't need multiple DAGs for the different scenarios. At the end, both the branches join together and the pipeline completes cleanly. So this is a good example of real business pipeline which is structured, parameter driven, and integrated completely with the Snowflake. Now, once this file is ready, all I need to do is push it to our Git repository. So let me just commit this file and push it. And yeah, that's it. There is no manual upload step. PyFlow continuously monitors the repo, so as soon as the file is detected, it automatically parses it and registers the new workflow. Now, if I go back to the UI and refresh the workflow page, you can see that the Snowflake Daily Ingest now appears here in the list. That's it. No configuration steps, no manual setup, no UI uploads. You write the workflow, push it to the Git, and PyFlow handles the rest. Now let's go ahead and trigger this workflow and see it in action. This is the DAG detail page. At the top, you have all the key info like the name, the schedule, when it last ran, who owns it, what tags it has, and the current version. You can also activate or pause it right from here using this toggle, and you have a big trigger button to kick off a manual run whenever you need. Below the header, you have a set of tabs. Let me walk you through them. In the overview tab, this tab gives you a summary like the DAG ID, where the file lives, when it was first created, and a description. And the next tab is the graph tab. This is the visual map of all the tasks in a workflow and how they depend on each other. You can see the flow, like the extract full runs first, then the load full, and then the join results runs after both of them complete. This is really useful when you are debugging. Like instead of reading the code, you can just look at the graph and immediately understand the structure of the pipeline. In the code tab, we can see the actual Python source code of this particular workflow pulled live from the GitHub. So if someone wants to know what exactly this pipeline is doing, they don't need to go open GitHub separately. It's right here. Now let's trigger this workflow manually. I click the trigger and this modal opens up. It shows me the parameter this DAG accepts, and this form is dynamic. PyFlow reads this parameter schema from the DAG definition and automatically builds this form. So if the DAG takes a date range or an environment flag or a file path, it shows up right here. I will fill in the values and click the trigger DAG. The run has been submitted. Let's go to the runs tab to see it. Here is our run. You can see the run ID. At the top, your run ID, also the what DAG it belongs to and its current state and how long it took. Now that you have all the two tabs like a task instance and the graph, in the task instance tab, we can see the every single task in this run, like its particular state in this run and which operator it uses, how many times it is retried, and its start time, end time, as well as duration. And here is something really useful. If I click on any task row, this logs panel opens up right here inline. I don't need to navigate anywhere. I can see exactly what this task printed, what it did, any errors it faced. Now let me switch to the graphs tab on this run. This is the same visual graph we saw before, but now each node is color coded by its actual state. Like green means it succeeded, red means it failed, blue means it's currently running, yellow means it is queued. So if something failed, you can instantly see which task in the flow is the problem without like manually going through the logs one by one, and you can click on any node directly to pull up the logs for that task. Now, before we wrap up, let me quickly show you the different workflow patterns that PyFlow currently supports. PyFlow is not limited to just simpler pipelines. It supports multiple orchestration patterns that are commonly used in the real-world production systems. Let me walk you through them briefly one by one. Firstly, we have parent to child DAG trigger. This allows us to one workflow to trigger programmatically another workflow. It is useful when you want to break the large processes into modular pipelines and orchestrate them cleanly. Next is XCOM data passing. This enables the task within a workflow to share the data with each other, making the multi-step processing seamless. Then we have runtime parameters. You can trigger the workflow from the UI and dynamically pass the parameters like dates, flags, and this makes the workflows reusable and flexible without changing the code. We also support the automatic retry logic. If some task fails during the execution, PyFlow can retry it automatically based on the configuration. Then there is a conditional branching. Workflows can dynamically choose the different execution paths based on the runtime conditions, like full load versus incremental load. And finally, there is advanced trigger rules. You can control exactly when a task should execute, whether after all upstream tasks succeed or if at least one succeeds, and like that, so on.